let's take a look on the second part. We're going to talk about what is the region of interest. In short, we always say ROI. I can show you what is ROI. ROI just simply like this one. You can see I'm showing an ROI to you. This is ROI. Right here, this is a region that I am interested in. So this is so-called ROI, okay? I try to circle some area, and I claim this is the area or this is the region that I am interested in. So you can think about this. If you are looking at, for example, an MRI, you may try to find out a lesion, a bad thing, or an abnormal thing from the imaging. Right? So for example, if you are looking at a brain MRI right here, you can see this is a brain. So for any doctors or for anyone right here, you may try to find out, for example, here is a lesion. It may be a tumor or something, and you want to circle it out, right? So you are doing, we say ROI. You can just circle it. This is so-called ROI, okay? And another thing is called stress holding. Stress holding. Okay, I can try to do some image process based on the image intensity. For example, if you can see something that is bright, that is white, you may have a very large intensity. If you see something like dark or black, it may have a pretty low intensity. You can try to make a cut. You can try to differentiate these two different things of the imaging using the idea of the stress holding. Just make a cut, okay? You will see the example. So again, I do prepare several different steps right here, so you can follow me and finish this example. So the very first part right here, you can find out that for today's folder, MI materials underline L8 right here. We do have another subfolder, data. Okay, and you may find out within this data subfolder, we do have 69 DICOM files inside. Okay, but I have to say these 69 DICOM files, okay, these 69 DICOM files actually belongs to 3 different MRI images. So you may not be familiar with MRI, but you can take a look right here. Actually, these 69 files belongs to this one, FSET2. This is just one kind of the MRI. You do have another kind of the MRI named as the actual spin echo SE-T1 post-contrast or anything, and another one, T2 flare. So even you put all the DICOM files within the same folder, it doesn't mean all the files belong to the same kind of the imaging. Some of them may be one kind of the MRI, or maybe a part of them are the MRI, a part of them are CTs. Anyway, it can be possible, right? So in order to differentiate them, okay, what you can do, again, we learned something about the DICOM info, right? You can always find out there is a field name, series description, under the DICOM meta file or under the DICOM text. It can help you what is the actual imaging series right here, okay? So now, I don't have time to let you, key in all the codes line by line. I don't have the time right here. So I'm going to do this with you, okay? So I think we do have a script. Should be this one, image exercise 08, okay? So I can open it for you right now. Just wait, okay? Let me open it. You can do this by yourself too. Okay, so now take a look. What we are doing right here, first of all, I think clear close O CLC, you know this, okay? No worry. And then you can see for dir path, this variable, I try to, assign the folder name. Again, you can see the period. Period means the current folder, right? And you can see this slash. This means the file separation. So the current folder, you can find out there is a subfolder data, okay? Just like this one, Okay, so I'm going to just assign this. Again, I use dir function right here to get all the information from this folder. However, I removed the period and the double periods right here from this dir info. Okay, again, this is what we did before. And now from lines 9 to 14, these are very important. I try to get the information about the series, right? I say we do have 3 different series, different types of the images. I need to get the information. So now, again, I start by create a variable. But now you can see this is not the normal empty matrix. I use the curly brackets, right? So this is an empty cell array. You can just take a look. I can copy it. Let me clear everything. Okay, when I put this in, you can see in the workspace, I can see this variable. And this is not simply an empty matrix. It is empty, right? But this is an empty cell array right here because I use the curly brackets. Okay. And then you can see the for loop right here. Again, the for loop should go for the very first number, y right here, to the length of the dir. Okay, to the length of the dir. So maybe I can resume. Okay. I cannot use the hotkey right now. Yeah, good. So anyway, let me just do this. I try to get this one. Okay, so you can see if I run the previous part right here, you can see the dir info. Okay, 69 by 1, right? I do have the 69 DICOM files within the folder, right? So you can see the name. Okay, from 1 to, anyway, you can see 23 right here. But we do have multiple 23. Here is another 23. Here is another 23. I do leave some hints for you. You can see 001 means these are the first type of the MI. So you can see 001. But start from this one, you can see 002. Okay, so this is for the second type of the MI. And this is the final type of the MI. We do have 3 different types of MI. Okay. So not only I can get the directory information, you can see within this for loop, I use the DICOM info. I don't need a space right here. I use the DICOM info, okay, to get the information of the current file. Do remember, I do have the 69 files, right? And I will go through 1 to 69. Every single time I can get the DICOM info right here. But do remember, I would get this specific field of info, okay? So let me do this for you. Just wait, it is busy right now. Okay, so now you can see info, okay? And again, I introduced this before. You don't really need to go through all the information right here because it's just too huge, right? What you can do, you can simply just type in info dot. And I know it should be something related with the series. So you can see series date. That means what is the exact date that you get this information. But we are going to go for this one, series description. So let me ask this. So you can see this is the DICOM information for the last. You can see the I is 69 right now. So this is the DICOM info for the final DICOM file right here. And you can see the series description is like this one. But you may find out that within the for loop, what I'm doing right here, again, I try to assign every single series description into this. Originally, it is the empty cell array, right? But within the for loop, I try to assign all the information into the series description variable right here. So now you can see after this for loop, the series description, okay, this variable, it just grows, right? It now has the size of 69 by 1. Double click on it. Now you can see I extract all the series description into this variable. So now you can immediately see, yes, I know this is the very first type. Even I don't know what is the FSET2. Anyway, I know this is the same type of the MI. And this is the second type of the MI, right? And the final one, this is the third type of the MI. Okay. So if you do this, it can help you to immediately understand all the series description for all the DICOM files, okay? For line 14 right here, you can see I used a new function right here, unique. I think if you know this English word, you will immediately get the point. What is unique? I just want to get which 3 types that we do have, okay? So if you use the unique, it will automatically get rid of the same series description. So even though I do have the 69 series description within this variable, right? I can use this unique function using the series descript variable as the input. You can see the result. It will reduce the size from the 69 to 3 by 1. Why? Because it will get rid of all the same results. So the unique answer for the MI type right here, you will see, okay, I only have these 3 types of the MI. Okay, so this is again very useful function. You can just try to help it unique. Okay. So again, I'm going to pause right here, like 1 minute. You can read through the very first part right here and make sure you do understand me. Okay, you do follow my path. And again, if you do have the question, just raise your hand. Okay. So again, I just want to emphasize that within this info variable, this one, within this info variable, we do have so much information inside. Okay, so you can just spend some time on it. If you do really want to know the medical imaging information, you can spend some time to browse, to go through all the field name, so you may get a general idea about what we can access, what we have within this kind of the DICOM information. Okay, sometimes we say this DICOM information is metadata because this is big. Okay, it just stored lots of different items or variables inside. So series description just one of the item. Okay. Okay, so I do see some of them are still asking the question. I can just wait for another 30 seconds, then I need to proceed. Okay. Okay, so I think it's about time. So let me take the control back. If I do interrupt you, I'm so sorry, but I need to control the time. Okay, so step number 2. So now if I can, just categorize all these 69 files into 3 types, I think we can do more, right? Now, I think the second step 2 is not that hard. We are going to sequentially display the target series. So target series means you need to identify which one. You have 3 types, right? You need to identify which one is your target, okay? So for example, you can see the example right here. This is the so-called post-contrast imaging. That means we do use the contrast agent to enhance this tumor lesion right here, okay? So you can see the second part of the same M file. I assign the target series. Again, this is simply a variable, but I try to assign the target series name right here. Actual, spin echo, T1, post means post contrast. That means you do use the contrast agent to enhance the lesion, okay? So this is your target series. Of course, you can change this name to, for example, T2 flare. We do have the T2 flare, right? So you can change the name. But right now, I'm going to go for this post contrast enhancement T1, okay? And for the line 19 right here, again, this function, we used this before, right? For the week that we are talking about the XLS read, we try to find out the female from the Excel data, remember? So we use the X-member to compare the data information with the target. For that time, the target is female. The characters like the female, okay? But right now, you can see the goal or the target right here is the AX with the space SE with the space T1 with the space post right here, okay? But again, we are going to use this is member function to help us actually get the indices for the target series. So you can think about this. For this variable, it has the length like the 1 by 69, or maybe it should be 69 by 1 anyway, 69 by 1. After using this as member, I will get the check with all the 1 and a 0. 1 represents that for a specific image, it does belong to the target series. Otherwise, if you get the 0, that means it doesn't belong to the target series, right? So I can do this for you right now. Go to the step number 2 right here. Okay, so I can simply, maybe I can just copy it. So now you can see the check. Again, 69 by 1. It should have the same length with the series descriptor right here. If you double click on it, again, you can see this is either 0 or 1 right here. So if I put the series descript on the right-hand side and the check value on the left-hand side, again, I want to emphasize they do share the same size, right? 69 by 1, 69 by 1. So because the target, of course, the target for the, I think for the first image to 46 image right here, they are not our targets, right? So you can see 0 right here. 0 means false, But start from the 47th image right here. You can see this series description definitely match with our target series name, right? Actuals being equal T1 post anything. Okay, so you can see from 47 to 69, they are all ones right here. Okay, so basically, its member can help you to get whether it is or it is not your target. Okay. So of course, we are only interested in the images that matched for our target series. So you can see we use the find right here. I use find to find out the indices for the check. So basically, this line will give you the exactly, I think, yeah, this one. It will give you the exact values for the image you want. So you can see basically the indices start from the 47 to 69. There are the images that you are going to use, right? Okay, so this is how you use find right here. And then I think start from the line 21 to 30. You should be very familiar with this one. Why? Because this is what we did before, right? Now you can see if I run this part, Okay, just start from 21 to 30 right here. I just run this part. Then you should be able to see the image right now. Just wait. Okay. So now you can see, because I put a pause right here, so Manable would wait for your command. You should press any key, right? You should press any key. Then Manable will proceed to display the next image. So basically, you are stuck in this for loop because you didn't press any key right now. And now there is something different right here. You can see there is a small number, okay, above this image right here. You can see 1, okay. And once I press any key, you will see now the image is changed, right? And you see the number jumps to 2. I press the button again and again, right? If I keep just pressing my, any key on my keyboard, you can see now not only the image slice continuously updated, you can also see the value is continuously updated because I use this one. This title function can help you display some information above the image. So this is why it is called the title, right? Something above the image. And you can see, again, I use number to string to display this I, because I itself is a value, is a double value, right? So I need to use the number to string so I can print it out, because title is also a function to print out string or character above the image, okay? So this is something that you can learn, okay? So this is for the second part. But I think the second part is pretty straightforward, so I don't want to stop right here. Let's just go for step number 3. Step number 3, okay, if I do see the legion, just like what we displayed, right? For this sequential display, I do see some legion, pretty similar to this one. You see something wrong. Even you don't fully understand what is MRI, but you can just make a comparison between two brain hemispheres, right? You can see there is something different. Okay. So again, step number 3, if you are the doctor or if you are some guy, you are someone that you are going to process or analyze this imaging, you can just create so-called a region of interest. Okay, so basically you can call for a function and then you can use your mouse, use your cursor with left click. Every single time you click on the imaging, you will create a dot. And this dot would become the vertex of this polygon. Okay, so you can click on here, you will get a new vertex. Then you move your cursor to next one, you click on it, you will create another vertex. So you can do it one by one until you finish the creation of this polygon. Again, this polygon is so-called region of interest because you are interested in something, within this area, right? And after you finish it, you can actually create a so-called ROI mask. Do remember this spatial word, mask. Mask means, something either 1 or 0. 1 means the region that I'm going to preserve, that I'm going to use. 0 means something I don't like. I want to get rid of it. I want to remove it. So think about this. If I can create this kind of 1 or 0 mask, I can directly multiply this mask with my original imaging, pixel by pixel. What does that mean? Think about this. If you have any kind of a number multiplied by 0, what would happen? You will get 0, right? If you have any kind of value multiplied by 1, you will get the value itself, right? It won't change anything. So this kind of mask can give you the effect that if you multiply this kind of the mask with the original imaging, again, pixel by pixel, element by element, point by point, it will help you to only preserve the area that you are interested in. And for other area, it will turn into black. That means 0, right? Because you multiply them by 0. Okay, let's just do it step by step. So let's take a look right here. First of things, you need to find out a specific slice because you have 23. Yeah, you have 23 slices for this target series, right? You need to identify which slice you are going to drill, you are going to contour, you are going to create the ROI, okay? So you can see right here, I just specified the target slice as 14. I do have the 23 slices for T1 post-contrast imaging, but now I try to pick the 14. So you can see now I use the figure and the image show to display this imaging, right? And now for line 37, this one is very, very important. ROI poly. ROI poly is a building method function. It can help you to create an ROI. So I'm going to do this right now for you, just for this part, okay? So let me do this. So you can see, I need to stop, yeah. So now you can see this is the target slice. Again, this is the 14th slice, right? So now you will find out if you call for this function, ROI poly, you will find out your cursor become the crosshair. Can you see that right here? It is a crosshair right there. This is no longer the mouse cursor, right? This is now the crosshair. So what you can do right here, you can, of course, move your mouse. It's okay. Once you determine to create the very first vertex, just left click on your mouse, okay? Just for once. then you will see now, once I click it, I just release the left button, okay? Then you can see now I can again move my mouse until I determine the next vertex. For example, I want to put the next vertex right here. Then I, again, left clicked on my mouse. You will create a second vertex, right? So you can do this just repeatedly until you come back to the very first vertex. Just take a look. Once you move your cursor back to the very first vertex, it will become a circle. Can you see that? It is no longer the crosshair. It will become a circle. So that means you are going to close the loop. You are going to close this area, okay? So for this kind of situation, you need to double click. For the last vertex, you need to double click on the left button, okay? Double click. Okay, then the polygon will disappear. But based on my code, you will see this kind of mask, okay? Because for the next part, you can see I try to create a new figure. Again, I use a subplot. I'm going to create a 2 imaging in the layout like 1:2. But for the very first imaging, I'm going to simply display the mask. The mask is what you get, what is the output of the ROI poly. So take a look. Mask right here, it has the same size of the original imaging. Okay, but within it, only the region within the area that you are interested in would be 1. So let me use this one. You can see the index is 1, right? It should not say index is the intensity or the value. The value is 1. But outside, you can see the value is 0. Okay, so basically this is 1 or 0, or maybe you can say true or false matrix right here. Okay, but do remember, it has the same size. It has the same size with the original imaging, okay? So I'm going to ask you, let me give the control back to you. I'm going to ask you to perform the step 3 right here and try to use the ROI poly by yourself. You should learn how to use the ROI poly, okay? And if you do have the problem, just raise your hand, okay? Make sure that you know how to use the ROI poly, okay? And you should see the ROI mask right after you finish the creation of the ROI. Okay, so do it now. So again, I'm going to show you again. I'm going to show you again how to create the polygon. Okay. So do remember, you can anytime just adjust the size of the window. So you can just try to make it larger so you can do it right. Okay. So anyway, so now you can just click on anywhere. You can do it as close as to the region that you want, okay? You can do it anyway, okay? So basically, I think all of you can finish this step number 3. Then you can see the step number 4. Let me show you the step number 4 right here. Now you can see this is so-called stress holding because I am going to get rid of the pixels, okay, or elements that has the intensity or value lower than 1,700. I'm going to do this, okay? So maybe I can do this step by step. How about let us start by this one. Let's take a look. What does this mean? This means I'm going to get the target slice because target slice right now is 14, right? And the image itself is a 3-dimensional array. So the size is 512 by 512 by 23. And because of the target slice is 14, so basically this code will help you to get imaging, I think just like the 112 by 112, right? And then you can see I use this one, dot multiplication, right? So basically, I'm going to do something like element by element because I use the period, okay? So as I mentioned before, mask itself is either 0 or 1. So only the area within the ROI would be 1. So you can see, if I do this, let me take a look. So you can see the result would be like this one. Take a look. Basically, what I did is multiply this binary. Sometimes we say binary. That means I only have 2 values, either 1 or 0, so binary. Binary mask with the original image. So you can see this kind of the result, right? For other region, they are all 0. But within this area, they are the original value, okay? But I have to say, sometimes this is not good enough. Because, for example, in this case, this is a malignant tumor. And sometimes I just want to know which part of this malignant tumor is the most malignant part. That means the most terrible part that I definitely need to, resect it or get rid of it. So if I really want to answer this question, what I can do right now is I can do the stress holding. So basically, you can just check the value right now. The value right here, you can see for the brighter region right here, it's around 1,000 to 2,000, I have to say. Like the 3,000, 2,900 is pretty large, right? But if I move my cursor, my data cursor, within this gray area, you can see the value is only around 1,200, right? So now I can make a cut. I can make a cut by using a proper value. For example, 1,700. Okay, I know this because I just checked the value before. I know 1,700 can help me to get rid of this so-called gray area right here. So let me show you this part. Not only use this kind of the element-wise multiplication right here, I also do these things. You can see I add this part. What does this mean? This means I only want to preserve the region larger than this 1,700 right here. Okay, so let me just put this right here and let us see the result. So now you can take a look. If I add this condition right here, then means I simply ask which area has the value larger than the threshold. Right now the threshold is 1,700, right? 1,700 right here. So now you can see the result is a little bit different. I just want to know where is the area that possess the value larger than 1,700. Okay, so you can see the result is pretty different from the previous one because the previous one only give me the result that the original value within the ROI. But what I'm doing right now, I take a further step. I'm asking which pixels are really possess the value larger than 1,700, right? So you will see the answer. Again, it's just a yes or no, right? Whether it is larger than threshold or not. So you can see this is a yes/no question. Okay, so you can see, okay, for the area like the white area, you will see the value is 1. That means true. For the black area, that is 0, representing false, right? Okay. Okay, so I think this is the idea that I really want to show you that you can do these kind of things to, again, step by step to really get the information you want. What is the most malignant? What is the most terrible region of the tumor? I really need to treat it. I really need to perform some therapy on it. Okay. Okay. So, any questions for this part? Any question? So I think this kind of the exercise. Let me show you. You can do something more right here. Again, let me just get rid of this larger than threshold description right here. Again, this is a result, right? Can I just get the indices for the pixels with the value larger than 1,700. Just take a look. How about this one? If I try to write down something like this one, okay, tell me, what does this mean? The ND right here now record or just store the location or indices for the pixels with the value larger than 1,700, right? Okay, so this is a little bit different compared to the original description. It just helps you to get the indices. This is pretty similar to what we practice, that we can identify the elements with the value higher than a threshold or than a target, right? So I'm going to show you something. I can actually do something that I just want to remove the value lower than that one, okay? So maybe I can do this. This is the way, right? Or maybe I can do this. Now, let's come back to this one. Again, we said this one is either 0 or 1. So how about this? I just want you to compare these three different descriptions. So think about this. How about this one? Okay, think about this. How about this one? Now I try to multiply my original imaging with this mask threshold. And you can see now I only preserve the area or the region with the value larger than threshold, right? Okay, so what you will see right here, let me show you the results. You can also create these kind of things. This is the original value from the image. You can see this is not purely white and black. You can see some gray value right here. Because what I'm doing right here is I multiply this final mask with the original image. And you can see these criteria, go with the threshold 1,700 right here. So you can also acquire this kind of result. So basically you can see three different presentations right here. The first one, you see the whole area with the original value. The second one, you only see the area with the value higher than 1,700, but it is still a mask because you can only see 1 or 0, right? The final presentation right here, you can see now it is not simply a mask. This is a mask multiplied by the original image. So I can preserve the original value. You can just click on it. You can see the value right here is the original value, like 2,000 or something. Okay. So you need to think about this. What do these three different presentation means? Okay. I think they do have some different function or different meaning behind it. Okay. Okay. So I think it's about time. Yeah, so anyway, you can see today we don't have the homework because I know next week we are going to have the midterm computer test. So I would say today's homework is no homework, but I do suggest all of you to confirm. I mean, to check all the previous homeworks again. You need to check that you can finish all the homework and you did finish it before. If you didn't, do it now, okay? Every single homework is pretty important, okay? And I have to say, next week, you should not have any other midterm test, right? I'm not sure. But anyway, please prepare MATLAB midterm exam. I say wholeheartedly. That means with your full heart. Just prepare it well, okay? So good luck on your next week midterm exam. You should bring your own notebook. Prepare all the materials like the homeworks or handouts you need. You are not allowed to use internet to discuss with your classmates or search for the answer on the Google. It is not allowed. But you can use all the resources that you pre-downloaded into your computer. You can use all of them, okay? So anyway, if you do have the question, please come to me or raise your hand. Otherwise, you can feel free to leave this classroom. So see you next week, okay?